Hello everyone, welcome back to part 2 of our COMSOL tutorials. Today we're gonna be doing an example of the COMSOL transport dilute species and laminar flow features. Since this is one of the most crucial features that you need to know when you start creating simulations in your bioengineering career. So what is transport dilute species and laminar flow? So transport of diluted species is used to compute the concentration field of a dilute solute in a solvent. The chemical species doesn't necessarily need to be dissolved in liquid. It can also be dissolved in a solid or in a gas. And for laminar flow, it is used to compute the velocity and pressure fields for the flow of a single phase fluid. So without further ado, let's get started. So for today, we are going to do an example of a microfluidic system that simulates the function of the human heart. So as you know, there are different parts of the heart that you can be represented by 2D models using COMSOL. So we're going to do that. So first, we're going to select Model Wizard and select 2D as our space dimensions. Then we add a study, which is transport of dilute species. So it's going to be under chemical species transport. Then you pick transport of dilute species. That is going to take a few seconds. And you do the same thing for laminar flow, which is under fluid flow, single phase flow, and there it is, laminar flow. Add it in a few seconds, then click study. So for this study, we would want to make a stationary study just because we're not changing any variables over time. You can do that if you want to, that's totally fine as well. Depends on your model and what you want from your simulation. So click done. Okay, so now you have this. So the model wizard was very helpful in taking care of setting up the simulation features. Everything is set. So now we want to make the 2D heart model. Now, if you took like a basic biology or even anatomy class in high school or in college, you probably know the 4 different chambers of the heart. The left atrium, the right atrium, the left ventricle, and the right ventricle. In order to show that, I will use 2 squares and 2 rectangles to start in creating the chambers. In this demo, I'm going to keep the heart inverted along the y direction. What I meant by that is that I'm going to use the left side to put the right atrium in the right ventricle. And then I'm going to use the right side to put the left atrium and left ventricle. Just because I'm used to that in simulating heart and I've been doing a few of these simulations in that way. So you can do it the regular way if you want to, but I'm just, in this example, I'm just going to do it that way. So I'm going to set the units in geometry to the appropriate levels. You go to geometry and pick the length of unit as centimeters, since I believe that's the most appropriate length unit for measuring a human heart. So from there, you right click geometry, you add square one, and you have to pick the size of your heart, which is usually the atrium are around 4 centimeters in each side. And from there, you can coordinate at a position of y at 4 and 0, x at 0 for the left atrium. And that's your, that's your left atrium. Now for your right atrium, you pick another square, again 4 centimeters in side length, and you'll position it at 4 by 4. Selected, and as you zoom out, you can see that the two squares are next to each other. So you already built your to the left and right atrium. This time I'll do the ventricle. So for the ventricle, you also want to show that with 2 rectangles below the atria. So we right click, we already added rectangle 1. We're gonna have this as a width of 4 and a height of 8. And we want to position that at 0, -4. So selected. If you zoom out, you can see that the rectangle is positioned as such. And next you have to do the other rectangle with same units, just at different position. So same size, same shape, but with different position. 4, I'm gonna position at 4 and -4. So now you have the 4 chambers of the heart. Now you're done with the chambers of the heart. Now we can simulate the veins, arteries, and vena cavas for the heart. So these are like the main vessels that connect the heart to the rest of the body to supply the blood. So in the left atrium, which is represented by this square, we have the pulmonary veins to let blood flow into the heart, and the left ventricle, we have the aorta, which remove the blood from the left ventricle out to the other parts of the body. So on the other side, we also have the vena cava at the right atrium, and then we have the pulmonary artery attached to the right ventricle. So we're gonna simulate those parts using a bunch of like rectangles, all 1 centimeter wide, and 5 centimeters to. So let's do that. We add 2 pulmonary veins to left atrium. So we'll add a rectangle that is 5 centimeters long and 1 centimeter in height, positioned at X at 8 and Y at 5 centimeters. As you can see, appeared, build selected. Once we click the build selected, let's add another one. We'll be putting this at width at 5 with a height of 1 at X equals 8 and Y equals 7. Okay, so we have that. Then we have the 2 vena cavas in the right atrium with width of 5, a height of 1, positioned at X equals -5 and Y equals 5. And another one with another rectangle. We have a width of 1 and a height of 5, positioned at X equals 2 and Y equals 8. So if we zoom out, now we have all of the, I guess you say, entrance of the blood to the heart. So that's nice. Now we're gonna do 2 more rectangles to show the other 2 exit pathways for the heart. So we add the where the blood flows out with the heart, which is the aorta on the left ventricle, and the pulmonary artery on the right. So we add a rectangle with a 1 centimeter, height of 5, with cornered at x equals 1 and y equals -9. We do the same thing for the other side. With a width of 5, height of 1, at x equals 8 and y equals -2. Now we're done with the geometry of our model, which is great. After all of those rectangles added and squares added, we are now done with the geometry.